Okay, in this video, we're going to work a bunch of problems using the chain rule. The level of difficulty of these problems will be beginner to intermediate. In a separate video, we'll do advanced level problems. So feel free to pause the video before each problem, try it yourself, give it your best effort. Maybe you even want to read some of your book material or watch other YouTube videos before trying the problem. Then give it your best effort, watch the solution. Then before the next problem, go review a little bit more. Then try that problem. That's a great way to learn the material. For the first problem, I'll give a lot more explanation on how to do the chain rule, the theory behind it. Once I've explained how to do it, we'll start just going through the problems so we can get more problems done. Okay, so let's get started. So for each problem, we're given a function of some variable, and we want to find the derivative of that function. So here we want to find f prime of x. So to use the chain rule, you really need to know your base derivatives. So like the power rule. So x to some power, right? You bring down the power and then x to that power minus 1. You need to know that. Like derivative of sine of x is cosine of x. The derivative of 2 to the x is 2 to the x natural log of 2. So all of those base derivatives you need to know in order to apply the chain rule. And the reason is because when doing the chain rule, you take a look at the function you have and you break it down into those base derivatives. So like here, you start with the biggest picture possible. So like, what do I mean by that? So here we've got something to the fourth power. Okay, you can see that this could be absolutely anything in the parentheses here. We've got something to the fourth power. Well, we know how to take the derivative of something to the fourth power. Right? Let's use s for something. So d derivative with respect to s of or let's do s to the fourth of s to the fourth. Right? The derivative with respect to something of that something to the fourth. Right? I know it's a little weird using the word something, but that's kind of what a variable is. Is what? We know this. 4s cubed, right? And all the chain rule is saying is that, so technically to finish this derivative, we would say, okay, derivative with respect to something of something to the fourth is equal to 4 times that something cubed times the derivative of that something times, but this is just 1. So we don't write that. But in this situation, we say, okay, we've got something to the fourth power. The derivative of that is 4 times that something, whatever it is, right? Imagine that this is s, or imagine that this is s. So would I just write that something no matter what it is? Cubed, right? Times, and just like we did when we had ds, this would be d 5x cubed plus 2x cubed dx. Well, that's not 1, right? That's not 1. You see what I mean? If you imagine that this is s, we did d ds s to the fourth, 4s is equal to 4s cubed times ds ds. That was 1. Here it's times d this dx. Well, that's again, that's not 1. That's 30x to the fifth plus 6x squared. You see? So that's the idea of the chain rule. And so like you might be kind of wondering, where does this come from? So, another way of looking at this, kind of the general formula for the chain rule. So if you've got f of g of h of x, then df dx, right? Derivative of f with respect to x. Like just so you're not confused. Like this is right here. You can write this as f of h of x, where h of x is equal to 5x to the 6th plus 2x cubed. You see? This just has one additional g. This has even another, there's a subfunction within the subfunction for this example, right? Kind of like if this was, and the inside was sine of x cubed, right? You'd have the sine function is the g, and the h function is the x cubed. But so the derivative of f with respect to x, which is kind of what we're trying to find here, is just df dg times dg dh times dh dx. And you can imagine like all of these canceling, and you get what you're looking for, right? So that's what we're doing here. It's df dh, which is what this is, times dh dx is what we did in order to get this f prime of x. So this is f prime of x right here. I mean, we just wrote it out. This is it. But for these problems, you want to put your derivative in the simplest form possible. So you want to factor it, simplify it. Okay, so to simplify this, let's take out factors within these two expressions here. So we can take out here a 2x cubed. So you get 5x cubed plus 2 cubed times, here we can take out a 6x squared. So 5x cubed plus 1. Okay. So let's bring this 6x squared to the front. Oh, wait, what did I just do? I can't take out a 2 here. This is just x cubed. Okay, so let's bring this 6x squared to the front, and then this x cubed, but this is actually x to the 9th. So you've got 6 times 4 is 24, and then x to the 9th times x squared is x to the 11th. Okay, and then 5x cubed plus 2 cubed, and then 5x cubed plus 1. Okay, and that is your answer. Okay, so we want to find f prime of x. So again, looking at the biggest picture, what do we have here as terms of the base derivatives that we know? Well, you could rewrite this as, okay, and then you could say that our biggest picture is something to the 1/2 power, like, so then we could do the power rule, but I have it memorized, and you might have it memorized too, that d dx of root x is 1/2 root x. So I'm going to say that our base derivative, I've got the square root of something. Okay, so again, using the chain rule, just first take the square root of that something is just what? So 1/2 root of that something. So okay, so now times the derivative of that something, right? If we were over here, we would say The d dx of root x is 1 over 2 root x times the derivative of x times dx dx, right? This is just 1, so we don't write it. So you're kind of, even when you do regular derivatives, you're doing the chain rule and you're not realizing it though, because you're multiplying by 1. Here, it's like, again, the derivative with respect to something of the root of something is equal to 1 over 2 times root of that something times the derivative of that something with respect to that something. X is just something, right? A variable, you can just look at a variable as just something, but here it's 1. Here, now we do the derivative of that something with respect to x. That's not 1. That is, so the derivative of 5x plus 1 with respect to x is 5. Okay? Okay, so and that's your answer. Okay, so the biggest picture we've got the cosine of something. Okay, we know how to take the derivative of cosine of something. That's just minus sine of that something. Okay, times the derivative of that something. It's not 1 in this case. The derivative of theta squared with respect to theta is 2 theta. Okay, so f prime theta, just write it, that's your derivative, but just put it in the cleanest form that you can. Bring the theta to the front. There you go. Okay, so this is getting a little tougher just because we're going to be doing the same thing. We're going to be doing the chain rule, but there's going to be a lot of other processes mixed in that potentially will confuse you. So here we've got a function of t times another function of t. So we need to use the product rule here. We're going to have to use the chain rule mixed in. So we've got, okay, so product rule. Derivative of the first, but we need to use the chain rule here. So derivative of e to the something is just e to the something times the derivative of that something. Derivative of at with respect to t is a, okay? So that's the derivative of the first times the second, just the second as it is, okay, plus the derivative of the second, so we've got to use the chain rule again. The sine of something, derivative of the sine of something is just cosine of that something, okay, times the derivative of that something. It's not 1 in this case, it's derivative of bt with respect to t is b. Okay, derivative of the first times the second plus derivative of the second times the first. Okay, so that's your derivative. Now we just need to write it, just clean it up. Now we can factor out that e to the at, and that is your answer. Okay, so similar to the last problem, we've got one function of x multiplied by another function of x. So we're going to need to use the product rule. So f prime of x is equal to the derivative of the first. We've got something to the 4th power, so 4 times that something cubed, right, times the derivative of that something. Derivative of 2x minus 3 with respect to x is just 2. Okay, so that's the derivative of the first times the second. Just write the second. plus the derivative of the second. So something to the fifth power. First take the derivative of something to the fifth power times the derivative of that something. Derivative of x squared plus x plus 1 with respect to x is 2x plus 1. Okay, times the first. Right, derivative of the first times the second plus derivative of the second times the first. Okay, so I mean that's it. That's your derivative. Now it's just algebra, factoring, cleaning it up. So f prime of x is equal to, what can we factor out here? So we could take out a 2x minus 3 cubed and an x squared plus x plus 1 to the fourth. Okay. And then what we're left with is okay. Now, so let's just distribute all of this, because this out front is good, but let's distribute all of this. So this is okay, so what we have is f prime of x is equal to and that is your answer. Okay, so this is pretty much the exact same thing we did in the last problem, except it's a little more complicated because you've got this 2/3, but you've got one function of x multiplied by another function of, or functions of t. One function of t multiplied by another function of t. So we're going to use the product rule. Okay, so derivative of the first. Derivative of the first. This is something to the 2/3 power. So 2/3 times that something. Okay, and then to the 2/3 minus 1. 2/3 minus 3 over 3 is minus 1/3. Okay. Okay, and now times the derivative of that something, but the derivative of t plus 1 with respect to t is just 1. So that's the derivative of the first. Okay, times the second. Plus the derivative of the second, so something cubed derivative of something cubed is 3 times something squared times the derivative of that something. Derivative of 2t squared minus 1 with respect to t is 4t. Okay, so we have the derivative of the first times the second plus the derivative of the second times the first. Okay, that's your derivative. So I mean, like you're as far as your derivative is concerned, you're done. I mean, this is messy, but you can look at this like if you carefully input this into Excel or like MATLAB or any kind of code. So you've got in one cell you've got your input t. You can put any t you want, any number you want, and then like there's a formula like a formula cell that has that t as an input, and you just put all of this. And you can also have a separate cell where the t is the formula itself. So if you put any t in, you get the output for that t, you get the output of the function, and you also get its derivative, right? So I mean, this is the derivative. You're done here as far as the derivative, but like, a problem on a test or just, many answers in calculus textbooks, they're going to want you to simplify this into the cleanest form you can. So this is all algebra, factoring, canceling, putting negative exponents in denominators where it's appropriate. So it's, or like converting 1/2 powers to square root symbols, things like that. So to clean this up, we can factor out a 2t squared minus 1 squared. And then we could also take out a t plus 1 to the minus 1/3. And that's helpful because like this obviously cancels, but then this, the 2/3 power becomes a 1 power because minus 1/3 plus 1 is equal to 2/3, right? So that's convenient. This obviously canceling is convenient, but this going to 1 is convenient. Okay, so let's write out what we're left with. Okay, but we can get rid of this fraction if we factor out a 2/3. And this becomes 18. That's where the fraction goes away. Right, 2/3 times 18 is 12. Okay, so this is okay, so what we're left with and that is your answer. Okay, so the biggest picture we've got is the square root of something. So dy dx is, so what is the square root of the derivative of the square root of something? It's 1 over 2 times the square root of that something, right? So now times, if this was just x, if we would be done, because derivative of x with respect to x is 1, but what is the derivative of x over x plus 1 with respect to x? Well, we have to use the quotient rule. That's why this is a little more advanced. You can see we're doing the same things. We have to use instead of just an easier problem, this would have just been x squared under the root. So the derivative of x squared with respect to x is 2x, and we're done. But now it's going to make us do the quotient rule. It's making us keep track of everything. It's trying to add levels of, not complexity, but just levels of things you need to keep track of. I guess it is more complex, but it's not, the theory is not more complex. Okay, so the quotient rule. Derivative of the top, 1, times the bottom, minus the derivative of the bottom is 1, times the top, all over the bottom squared. That's your derivative. You're not done. We have to clean it up, but that's your derivative. You're done taking the derivative. Okay? So to clean this up, we've got an x plus 1 here. So maybe we can combine these two x plus 1s. So let's rewrite this. We've got we can say that this is okay, and now so x plus 1 to the minus 1/2 times x plus 1 squared, that's minus 1/2 plus 2, which is 4 over 2, so 3/2. So we've got that. So this is x plus 1 to the 3/2. We'll keep that in the denominator. Let's bring this x to the minus 1/2 into the denominator to make this positive. And then we can turn that x to the 1/2 into a root x. and all that under 1. So there you go. That is your final answer. Okay, so we've got, again, our biggest picture, we've got something to the 8th power. That's our biggest picture base derivative that we know. So G prime U is equal to the derivative of something to the 8th power is 8 times that something to the 7th power, right? But multiplied by the derivative of that something, if this is not just 1. So to do this, we need to use the quotient rule again. Okay, so the derivative of the top, 3u squared, times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Okay, once again, that's the derivative. You're done with the derivative, but let's simplify this as much as we can. So let's bring this 7th power to each of these terms on the top and bottom, because then we might have we can combine like the u cubes plus 1. So okay, and we can do, let's simplify this on the side here. So the numerator, so you've got so this is 6u squared over u cubed plus 1 squared. So these u cubed plus 1 to the 7th and u cubed plus 1 squared, we can combine that. So u cubed plus 1 to the 9th. All right, and then 8 times 6 is 48. So 48u squared, and then u cubed minus 1 to the 7th. Okay, and that is your answer.